In this series of videos, we're going to talk about rigid motions. Back in middle school, you talked about geometric transformations. There are four of them. There's translations, reflections, rotations, and dilations. Now, we're not going to talk about dilations quite yet, not until much later in the year, because that's a little bit of a special case. But translations, reflections, and rotations are all really simple, common elements that are going to tie into the notion of congruence that we were talking about in the last week. So let's take a look at how these work. All right, this is a program called GeoGebra. It's www.geogebra.org. You can see GeoGebra, it's kind of a combination of geometry and algebra mushed together. So what you can do is you can make simple geometric shapes and then do some pretty cool things with them. I'm going to start off by making a triangle. All right, so there's our triangle. Its vertices are A, B, and C. And now we're going to talk about translations. Now, to specify a translation, I am going to create what's called a vector. We didn't talk about vectors when we talked about segments and lines and rays, but a vector is kind of a combination of a ray and a line segment. So it's got a distance and it has a specific direction. Like saying move 3 points over and 2 points down is an example of describing a vector. So let's see what happens with a translation. If I translate this triangle by this vector, I've got another triangle right there. You'll notice what happened with the names, that vertex A became A prime, B became B prime, and C became C prime. This is what's called the image triangle down at the bottom, and up at the top we'll call that the original triangle. So, is there anything you notice about these two triangles? And if you use the vocabulary that we set up earlier in the month, that would be excellent. These two triangles can be described by one of the words we used, and that word is congruent. These two triangles have the same size and the same shape. They're not the same triangle, but if we drew one on a piece of tracing paper and just scooted it over, it would lie exactly on top of the other one. And that's kind of the notion of congruence that we're going to have when we start out. So that is an important thing to keep in mind, is that translations are a transformation that preserve, is the word we're going to use, preserve congruence. So this triangle became a congruent triangle. If I looked at the line segment AB, the line segment A prime B prime is congruent to it. If I look at angle A, the angle A prime is congruent to angle A. So every part of that triangle is preserved as far as congruence goes when we make that translation. There's one other thing I want to look at. Instead of doing this with a triangle, why don't we do it with a line? So there's a line, and I will create once again a vector. And if we translate this line by this vector, what do you notice about the image line? So what do you notice about this line compared to this line? If I zoom out, maybe you notice these are kind of like railroad tracks. They stay the same distance apart. These two lines are never going to intersect with each other. The word we use, which is probably not going to be unfamiliar to you, is we're going to say that those two lines are parallel. All right, so we can use that as our definition of parallel, that a parallel line, two parallel lines exist if one is a translation of the other. Okay, so those are the key ideas you want to remember about translation, that they preserve congruence and that they create parallel lines.